Now, and we go to page 57 of handout. Page 57 of our handout. Now we want to do and as I've mentioned on Tuesday, we are all of you have used lathes and for when we are using a lathe, and if the cutting tool moves in this direction, and we will get a shape like this, right? And if we the cutting tool moves in a single direction like this and horizontally, and we will get this shape. And if we, of course, if our cutting tool moves in a circular path and 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 if we move in a circular path, you'll get a something like a sphere, right? The problem now is how do we guess the surface area or the volume of these shapes? How do we get the surface area? And volume of these shapes, okay? Of course, we can use integration to get these surface areas and volumes, but of course, integration is never easy. So we have got some rules to do this to get these surface areas and volumes. And after you have copied this, and please go to the next page, and I will talk about the next page, page 58. Now you take your time. For those who just come in, that there are handouts that you have. Everyone should get one sheet and one pile, and 一张加一叠哈。It's okay. After you have finished writing this, and we will go to the next page. But take your time. Now, and is that okay? If we are okay, that we go to the next page. Now, and we have two theorems, and the theorem of theorem of Pappus and Guldinus. So, and for these two, we have two parts of the same theorem. Now, and the first part is go to determine the surface area. And the Theorem II is talking about volume. And these two look very similar. These two look very similar. Now, and of course, the equations look like this. And let's go through the text, and let's go through this part. And now, and of course, we have 3 lines of English, and sometimes you may think it is very long, but it is not that difficult. Let's try it. And any words that you know are related to mathematics. First of all, we have is equal to, right? Is equal to. This is equal to. And then and we have times what? Times something. So times means is this one? It's okay. So it is equal to this area is equal to something times something. It's okay. Now, and here we have some words that is only used here, and in this paragraph, and this is the path. For example, if we use a lathe, that this is the path of the cutting tool, right? And then you move the cutting tool of the lathe here, and then the lathe is turning, and then we will get the area, right? You move the cutting tool of the you move the lathe cutting tool here in this way, and the lathe is turning, and then we get this surface area. So in this text, this path is called the generating curve. I think I should just put it like this. Generating curve is this one. Generating means this is the generating curve. Now, the surface area of surface of revolution is equal to the length of the generating curve. Here is we will say the length of the curve is L. Okay. Times now the surface area of surface of revolution A is equal to L times something. Now what's that something? We go to the next part. We go to the second line. The distance traveled by the centroid of the curve while the survey is being generated. So it means the centroid of the curve is point C here, and the distance traveled by the it means if this one is the distance traveled means the length it has gone, right? It has gone. So for this one, the distance traveled is this one. So if we, for example, if the lathe turns for one one circle or one round, that the centroid goes from here to here to here to here to here to here to here and go back to the original point, right? So this is the distance traveled by the centroid of the curve. This is the distance. This is the so it means the distance traveled by the center of the curve, which is this one, and while the surface is being generated. By the way, if something is turned by one circle, sometimes we will say, and this is one cycle. Sometimes we will say, we will say one cycle or one revolution. It's okay. In English, we would usually say one revolution. It means one cycle. So this is the English. It means the surface of area of surface of revolution A is equals to L times the length of this path. So the length of this path is equal to what? Equals to the radius of the circle. Radius of the circle and then times 2 pi, so 2 pi y bar. I'm not sure if I have mentioned those terms related to circle, and just to remind you. Okay, so and these three lines only mean the A is equal to L times 2 pi y bar. Therefore, this theorem 1 gives us a way to get translate a line to a surface area, right? And this is theorem 1. Take your time to write them down. And there is another theorem that goes from area to volume. For example, if we have a generating area, let me say A prime here. if we turn this area A prime by 1 revolution, that we will get a volume, right? If we turn this area, area by 1 revolution, we will get the area. And to get the to determine the volume from area, we will also do this, and then we take A prime, the area of A prime, and then we get the centroid of this area, and then because if it turns 1 revolution, this centroid travels by 2 pi times y bar prime, so it is so the volume would be equal to A prime, the area A prime times 2 pi y bar prime here. So this is the same. Using the same idea. Okay. Now, if you are okay with this, then we go to the single page of that I've given you today. This is the problem 5.56. And I think I've given you, I've put it on the iLearning, that this single sheet, and that pages 61 to 72, so you can download them. For those who come a bit late, and now we are doing chapter 5, and then the examination next Friday will be on chapter 6 and chapter 5. And then after chapter 5, I'll do chapter 8, chapters 8, 10, and maybe a bit of chapter 9. If you are okay, then we go to the example problem here. So, and the problem asks for the volume and surface area of the chain link. And which is made from 6 millimeter diameter bar. And if R equal to 10 millimeter and L equals to 30 millimeters, so this one is phi is equal to 6 millimeter. It's okay. Now, as you can see, and we are doing this problem in the because this chain link, you can see that it is you can see if we determine the surface area or the volume, that it is equal to this one and 2 of these, right? So how do we call this? How do we call these 2 shapes? The left hand one. Of course, you can see it in donuts, right? And sometimes in plain English, if you read magazines or newspapers, you will see donuts. But in mathematics, it is called a torus. And for the right-hand side, it is a cylinder. And of course, the right-hand part should be easy to you. The problem is for the left-hand side, right? The right-hand side should be easy for you, and let's do the left-hand side. Now, for the left-hand side, for the torus, it is actually it is a, you can say this is there is a generating curve here. And then it rotates this it rotates about this this line, right? It's okay. Now, where is the centroid of the generating curve? Of course, it is in the middle of the center of the circle, right? Let's let me copy the equation from the previous page. It is A is equal to L times 2 pi y bar, right? So L is the length of the generating curve, which is L here. And what is the distance traveled by the centroid, which is, it should be this one. And in the problem here, that it is given, it is R here. It's okay. This R is this R. So we have this is the equation given on the last page, but now we want to put it into our problem. So what is the length of L? L is equal to 6, because the diameter of the, sorry, if the diameter of the, because the diameter of the bar is 6 millimeter diameter. So what's the length of this generating curve? 6 millimeter times 6 millimeter times pi, right? And then we multiply by we multiply by 2 pi, and then R, which is 10 millimeters. And for the right hand side, it should not be difficult to use, because it should be because 2 times here, it is 2 times 30 times 6 times pi. This one is 30 here. The 30 millimeter comes from there. It's okay. Now, and after that, you should be able to calculate the total area. Let me put it A1 and A2. So A is equal to A1 plus A2. The answer is 2315 times, sorry, millimeter squared. Any problem with this? And after you have written this, you can think about how to do the volume part. How to work out the volume. The volume is also is equal to A times 2 pi y bar here. So you can think about it after you have written down the parts for the surface area. Now, if we go to the volume, that is the generating area, and that is the distance traveled by the centroid. Oh, sorry, I should say here. Now, the generating area should be the whole area here, right? And then if this area travels for one revolution, that will get the donut shape. It's okay. If this area goes through one revolution, and we'll get a volume. So, and what is the area of this shape, which is it should be easy to you, and this is pi over 4 times 6 millimeter squared, and then times 2 pi, because the centroid of the generating curve for this part is the same as the centroid of the circle. So the distance is the same. The distance is the same. So 2 pi times. So this is 2 pi times 10 millimeter. This is V1. And then we go to V2. V2 should be very easy to you. This is pi over 4 times 6 millimeter squared times 30. So the total area is equal to V1 plus V2 is equal to this one. It's okay. These are the two answers we need in this question. And this is the whole chapter 5 that I want to discuss.